Well, hello everyone. I am Snigdha Kakkad. This is my channel, AccelerateAICareers. Today we are going to solve a very interesting lead code problem, Leetcode62, unique paths. It has been a favorite of many companies, Amazon, Microsoft, Google, Meta, and Salesforce. In the last 6 to 12 months, they have asked it multiple times in their interviews. So let's dive into it. What is the question talking about? Let's see. So we have been given a robo here on an m by n grid where we have m rows and n columns. The robo is initially located in the top left corner, and this will always be the start index or the start point, grid 0, 0. That is the 0th row and 0th column. The robo has to try to move to the bottom right corner, that is grid m-1, n-1. The robo can only move either down or at right at any point of time. That means the robo can either go in the right direction or go in the down direction. It cannot go left, it cannot go up, it cannot go diagonal. So it has only two directions to take, either right or down. You have been given two integers m by n. You have to return possible number of unique paths that the robo can take to reach the bottom right corner, that is grid m-1, n-1th cell. How do we go about this question? So two things to note here is, if the robo chooses to go in the right direction, in that case it can never come back to this first column. It has to take options from this cell onwards, like from the first column onwards and all the rows. It cannot go to the 0th column. Now if the robo chooses to go in the downward direction, in that case it can never go in the 0th row. It has to make choices between the first row onwards to all the columns. So I hope that is clear, because it can take only right or it can take only down. It can never go back, that is taking left or up. So this is the first thing you should understand. Now let's look at an example. So here you have been given that m is equal to 3, that is you have 3 rows, n is equal to 7, that is you have 7 columns, and the output is given to you 28. So let's see how do we get this output 28. Now this is a dynamic programming question, and I must say that it is an easier dynamic programming question, not a difficult one. So I hope you understand how do we go about it, and then we can talk about how we code it. First of all, we need to find the number of unique ways the robo can take to reach this point, this end point from this start point, okay? That is our question. So how do we compute it? Robo can either go right or it can go down. Then if it comes down here, it can again take right or it can go down. Similarly, if it has taken right first, it can again go right or it can go down. If you see, to reach point 6, it has so many ways. Either it can go here, here, it can go here, here. So for every cell, we can cache what are the ways or how many are the ways to reach that point, and then compute backwards. So say suppose we know that the number of ways to reach here is these many. Then the number of ways to reach here is these many. So we can compute backwards. Starting from here, we can compute if it starts from here, how many are the number of ways to reach here. So how do you compute that? So as you can see, robo takes either right or down. That means the number of ways which it takes from starting from here to here, and the number of ways it takes when it starts from here to here, if we sum them, then we can get the total number of ways the robo takes from starting from grid 0, 0, okay? That's how we're going to compute it. And same way, the number of ways you can get here from here, so that can be computed by calculating number of ways it can reach the endpoint from here, plus the number of ways it can reach the endpoint from here, and so on. So if I say it's a DP question, we can begin from grid m-1, n-1. And from here, you can not go here, you cannot go here, you have only one way. So it's 1 here, okay? Now from here, there is no down, okay? There is no cell beyond it. So there are 0 ways to reach here. But there is one way to go, that is towards the right, hence 1 here. Now here also, there is nothing down, but there is one way to go, that is the right, hence 1 here. And if you see, the bottom row will always have 1 because there is nowhere to go down, right? Same way, in the last column, there is no way to go towards right. There's only one way, that is to go towards bottom, hence 1 here, okay? Now in this cell, if you see, the total number of ways to reach this cell is 1, and the total number of ways to reach the cell, this is 1. Hence, you can sum it up. So there are two total unique ways to go from here to the end point. Now same way we proceed here. The number of ways, unique ways you can go from this point to end point is 2, and the number of ways you can go from this point to this point is 1. So if you sum it up, it comes 3 here. Same way, if you sum 3 plus 1, it comes 4. So there are 4 unique ways to start from here and reach the end. Same way, 4 plus 1, 5. So there are 5 unique ways to reach here. Now from 5 plus 1, 6. So 6 unique ways to start from here and reach the finish line. Same way, 1 plus 6, 7. Now you can go upwards and check. So 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4, 10. So 10 unique ways if you start from here to reach the finish point. 5 plus 10, 15. 15 plus 6, 21. And finally 21 plus 7, 28. Those many are the ways to start from this grid 0, 0 and reach grid m-1, n-1. And that is your output as given in the example as well. So I hope you are clear how did we solve it. We used dynamic programming and we start from the very last cell where we want to reach and calculate the unique ways we can reach there from just the cell besides it. And that's how we go backwards. And finally we come till the start after summing the number of ways it takes to reach the cell just right to it and to reach the cell just to the bottom of it, because you can take only 2 directions, either right or downwards. Hence you are summing only the right cell plus the downward cell. I hope you understand the algorithm, how it works. Now we can look at how do we code it. Now as you know, we have m rows and n columns, and we know that in the bottommost row there is all 1 because there is only one direction to go. That is right, not towards downwards. There is nothing below the bottom row. So we can first initialize our bottom row. The bottom row can be initialized by n columns because there are n cells in all in each row, right? So I initialize it by 1. Okay. Now I will navigate and run a loop in range m-1 because I've already initialized the bottom row, so I don't need the bottom row. So remaining number of rows is m-1. Hence I'm running for m-1 rows. And I'll initialize my next row by 1 again, and I will keep on updating these cells. So now I have initialized. Now I will run an inner loop for j in range, and I have to run backwards because I will start from calculating this cell first, then this cell, then this cell. So I am going backwards, right? Hence, and I cannot start from here because I know that the rightmost column always will have 1 because there is only one way to go, that is downwards. So same as the bottom row, the rightmost column has already been initialized by 1, so I am not going to update it. I'm going to start updating from this column, that is n-2nd column, and I'm going to take every time one step before it, that is -1 step, and reach the -1 cell, hence the backward loop. And I will keep on updating the new row j value. And every value is a sum of the value in the cell towards it right and the value in the cell just bottom to it. So the value towards the right would be new row j plus 1. And the value to the bottom of it would be the old row. The old row would be row j. That would be the value here. And after that, I can update the old row by the value in new row and keep on updating this way. And finally, I need to return the result. I can return row, but I don't need to return the entire row. I just need the 0th index, which would be the value of grid 0, 0. And that's what I'm returning. Let's run it and see if it works. So it works. Let's submit. So it is a good enough solution. Now the time complexity here would be O of m cross n because you are going through the entire grid backwards. And the space complexity would be O of n because you are initializing one row which is of n cells, right? So that would be your space complexity On, and your time complexity would be O of m multiplied by n. I hope the solution is clear to you. If you like my way of solving problems, subscribe to my channel to get your updates for your daily LeetCode challenge. It keeps me encouraged, keeps me motivated to make more videos. If you have any doubts, ask them in the comments here. If you like this problem, also like, share with your network. Thank you.